Hello, my name is Muhamad Faisal and Muhammad Yusof. I am final year student in electronic engineering. So today I am going to share with you the result and discussion of Lab1, which is time division multiplexing in electronic communication subject as an assignment for this semester. So let's look to the result for experiment 1. For the channel in TP1, this figure shows triangle waveform, and this is the output that generate from TP1 port. So we can get the maximum amplitude without distortion by adjusting the value of VR1 and VR3. But by adjusting the clock knob, it will affect the period of frequency of the waveform generated. So for channel TP2, this figure shows the square waveform, and this is the output from the port TP2. It is the same. We can get the maximum amplitude without distortion by adjusting the only value in VR1. So for TP3, the sinusoidal waveform is the output for the port in TP3 as shown in this figure. And we can get the maximum amplitude without distortion by adjusting the value in VR2. So next, we go to the experiment 2. We can see here the green color represents the waveform of TP4, and TDM OP we can see on the yellow colors. So this is the output that generate from port TP4. And we can see here, TDM or OP signal shows a lot of distortion due to multiplexing. We know that multiplexing process occur in short of period of time. Because of it, it can cause the signal that mix each other and produce the distortion, and it can be shown in these pictures. So for TP5, it is the same. The green one represent the waveform of TP5, and the yellow one represent TDM OP. It is the same. TDM OP signal shows a lot of distortion due to multiplexing, and because of this multiplexing process, it caused the distortion. So for TP6 channel, the output signal generated from port TP6 we can see on green color and TDM-OP on yellow color. Due to a slight misunderstanding on the technical part, the square wave cannot be displayed for this TP6 signal. And the real one is shown in this figure 7, which is it is the actual waveform of TP6 green and TDM-OP on yellow. For discussion, there are 4 questions that we have answered from our observation on this lab. So for the first one, the question asks about describe how the multiple signals transmit to the same transmission channel. The multiple signals are transmit on the same transmission channel by using the multiplexing technique. Multiplexing allows a lot of signals to broadcast at various time intervals on the same channel. On a time, only one signal can transmit in a fast channel session, but in TDM, particularly, the overall transmission is divided based on the multiple signals that are needed to be transmitted over the common link. We know that each broadcast source is assigned one or more time slots in each frame for signal transmission. For question number 2, the question want us to explain the method of producing the sinusoidal waveform. A Wien bridge oscillator is one of the ways used to generate the sine waveform from a DC source. The fundamental components of the Wien bridge are 2 RC networks, one of which is coupled in series and the other is in parallel. The OPM is employed to provide a gain of 3 which are the compensate for the RC network's attenuation, and the R2 component distinguish the wind bridge fundamental structure from that the board the company used, which is ETEK ACS 300005. And the basic wind bridge is made up of a single resistor, but for this board it is built up to two resistors, one which is a resistor with two diodes linked in a parallel, and the other one is variable resistor, which known as VR2, and it is changed by the VR2 button. And next, question number 3, it asks us to explain the method of producing the square waveform. The OPM multivibrator architecture is used by the board to create a square waveform. The square waveform is generated by an RC timing network at the inverting input and the voltage divider network at the non-inverting input of the OPM multivibrator. When RC circuit capacitor is entirely drained at the inverting input, it charges until it hits the voltage saturation. Once the charging voltage of the capacitor hits the voltage saturation, the output switch state and it is driven to the opposite negative supply rail. When the output voltage, which is voltage saturation, is charged, the capacitor discharges to the new voltage out at a rate controlled by the RC time constant. The usage of the variable resistor in VR1 in the resistance component of RC circuit at the inverter input is one of the board change from the basic working OPM multivibrator circuit. And it causes the time constant to shift when the VR2 button is pressed. So for the last question, it wants us to explain the method of producing the triangle waveform. The triangle waveform is formed on this board by feeding the output of the square wave generator into the OPM integrator. This integrator gain is controlled by R5 and VR5 and VR1, while the square wave bandwidth is controlled by RB and VR3. As a result, VR3 and VR1, after we adjust it, the knobs, the generation of triangle waveform may be regulated. When a positive square wave peak is supplied to the integrator, the feedback circuit is bypassed due to a short capacitor C1 and it begins to charge. It also increases its impedance and hence the gain. So for the result, the amplitude of the ramp grows until the capacitor is fully charged. When the negative square wave peak passes through the integrator, the capacitor rapidly discharges and start to charge the opposite direction. And last one, the output will be a negative ramp since the condition has been reversed from this positive peak. So that's all for Lab 1. Thank you.